Hello and welcome. In this video, we're going to be looking at some examples of solving quadratic equations. Um, so of course, a quadratic equation is one where the x squared is the term with the highest power. Um, in this first example, we're going to be looking at a fairly simple one where the x squared is the only variable in our equation. So when we're presented with something like this, it's not really all that different than solving a normal equation with only an x. So to solve this, if we're ever sort of confused as to the order in which we should be doing our steps, we're going to need to remember our order of operations. And so, of course, when we are simplifying expressions, um, we start with anything grouped in parentheses, then we try to simplify exponents, then we would try to multiply, divide, add, then subtract. Of course, you may have seen this written out as the acronym PEMDAS. So if we were simplifying an expression, we would follow the steps in that order. But since we are instead solving an equation, we're basically going to work everything backwards to get to the missing value. So first we would look to see if there's anything we can get rid of by either subtracting or adding, which we don't have in this case. So then from there, we're going to look to see if there's anything we can get rid of by dividing, which would be the 3 in front of the x squared. So I'm going to divide 3 on both sides to get x squared equal to 25. There's nothing I can get rid of by multiplying. So then I'm going to look to see what I can do with the exponent. So basically, this is the added step that we haven't had in normal like linear equations that we're used to from Algebra 1. And so if we remember from previous videos, in order to get rid of an exponent, right, we're going to use a root or a radical. So if I see x squared equal to 25 and I want to simplify it, then I'm going to use a square root on both sides. And so taking square root of 25 will give me 5. If we remember from our video on complex numbers, when I square 5, right, if I do 5 times 5, it gives me 25, which is where that square root comes from. But we also know that if I do negative 5 times negative 5, that would also give me 25. So since I am solving for potential values of x, right, x could be either a positive 5 or a negative 5, and I would still get 25 as my value of x squared. So when I solve an equation by taking a square root, I need to note that the answer could be positive or negative. And we do that by putting a little plus minus sign in front of our answer. So if I was asked to solve the equation 3x squared equal to 75, I would get my answer as x is equal to both positive and negative 5. In our next example, we're going to look at solving a quadratic equation that's been given to us in factored form. So if we remember from our previous videos, when we have a quadratic that's in factored form, we solve for the roots or solutions by setting each factor equal to 0. This is what is called the zero product property. And so that's basically just another way of saying that if any of these factors is equal to 0, then I will get 0 as an answer when I multiply all of the factors together. So to figure out the values of p, we're just going to take each factor that has a p and set that equal to 0. So we're not super worried about the 5 because I don't see a p there. But 2p minus 3 and p plus 1 both have variables, so those are going to tell me my values of p. So to solve this equation, I need to figure out where either 2p minus 3 equals 0 or where p plus 1 equals 0. And so from here, we'll just solve each equation one at a time to get our two solutions. So to get the first solution, I'll add 3 to both sides to get 2p equals 3. And then we will divide the 2 on both sides to get p equal to 3 halves. And then to solve for the second solution, we'll take the p plus 1, subtract 1 on both sides to get p equal to negative 1. And since either answer could be correct, we're just going to put the word or in between them to tell us that these are both solutions to our equation. So if we've been given an equation in standard form, right, like x squared minus 10x plus 16, then in order to solve this, we're going to attempt to factor it first. So if we remember from previous videos, in order to factor an expression in standard form, the first thing we would look for is some sort of common factor between the terms. Since I do not see a matching variable in all three terms, and there's no number greater than 1 that divides from 1, 10, and 16, I know that there is no common factor, which means I'm going to need to set up my box in 2 rows to try to split this up and get the 2 factors that I'm looking for. So of course the x squared and the 16 comes down, and we're going to need to split up that negative 10x into 2 values that would multiply to 16. So of course I know that negative 2 and negative 8 will multiply to 16. I know that negative 2x minus 8x is equal to negative 10x. Which is what I can put in my box. So I need a negative 2x here, negative 8x here. And then once again, we go through and take out the common factors from each row and column. So if I go across the top row, x squared and x both have an x. If I go across the first column, x squared and 8x, again, both have an x. X times x gives me x squared, so I know I've got that set up right. When I go to the bottom row, negative 8 and 16 will both divide by negative 8. And then when I go across the second column, or on the numbers on the right, the negative 2 and 16 will both divide by negative 2. And once again, negative 8, negative 2 multiplies to 16, so I know I've got everything set up correctly. So my factored form then becomes x minus 2 times x minus 8 equals 0. Using the zero product property from the previous example, we can figure out the values of x by finding what would make x minus 2 0 and x minus 8 0. So if x minus 2 could equal 0 or x minus 8 could equal 0, then we can solve for our values of x by adding the 2 and the 8 to each equation, respectively. So our final answers are x equals 2 or x equals 8. All right, so in our last example, we're going to do what I mentioned in the previous example, which is to look for our greatest common factor first. So this equation has both x squared and x, which means that we're not going to be able to just solve it like we did in the very first example. But since I see an x in both terms, that's kind of my hint that I need to try to factor this using the greatest common factor. So once again, we said there's an x in both terms, so I know I can take that out. Also, 2 and 24 will both divide evenly by 2. So we know we can factor that out. If I then go back in and divide my common factor out, 2 divided by 2 will give me 1x right here. and then 24 divided by 2 would give me the plus 12, and then the x's would just cancel out when I divide. So my factored form of the equation would be 2x times x plus 12 equals to 0. And so at this point, we will use our zero product property to get the two values of x. So we're going to need to figure out what makes 2x equal to 0, as well as what makes x plus 12 equal to 0. So for the first equation, I'm going to divide both sides by 2. And of course, 0 divided by 2 is still 0. And then for the second solution, we'll take x plus 12 equals 0, subtract the 12 on both sides to get that x could equal negative 12. And once again, either solution could be correct. So we'll put the word or in the middle. And then use that as our final answer. That's all I have for this one. I will see you guys next time.